All right, so our warm-up was Joseph sold half of his homemade ice cream at the fair. If he still has 7 pints left, how much did he start with? So what are our thoughts, Gabby? 14. How did you come up with 14?
Because it happened on because 7 left.
Times it by 2. Good. So I assume the majority of you solved it that way. You just saw it. What is 7 half of? You don't need a whole paper for that problem. Or the rest of them. All right. So another way we could represent this is with an equation. So we're thinking, we know Joseph, he has some number of ice creams. So Joseph has some number of ice creams.
What kind of ice cream?
So we know he sold half of them, and then he has 7 left. How can I represent selling half of them algebraically? So we have divide by 2. If you divide something by 2, you cut it in half, you sell half of it. So we just made an equation from this situation. So we were given a situation, Joseph selling half of his ice cream and ending up with 7. And now that we have this equation, we can solve it. Now you may not have done this yourself. You might have just thought, what's half of 7, or what is 7 half of in your head. But you're really doing this process without even thinking about it. So how do we get rid of this 2? How do we solve and get that x by itself? Because remember, anytime we're solving an equation, we're always trying to get that variable by itself to see what it equals. So because we're dividing right here, we don't want to divide up here, but whenever we want to get rid of that number and move it to the other side, we're going to do something we call inverse operations. So inverse operation is always meaning opposite. So what's the opposite of division? Multiply. So we're going to multiply by 2. So we multiply this by 2. These cancel out. 2 multiplying by 2, dividing by 2 cancel out. But if we do something to one side, we also need to do it to the other. Why do we have to do it to both sides?
Because that's what you told us to do.
Because that's what I told you. Okay. What else? Why do we?
Otherwise,
You're uneven. So this is an equal sign. When we think of things equal, they need to be balanced. They need to be even. They need to be fair. If we multiply by 2 on one side, but don't do it on the other, things don't become balanced anymore. That equality disappears. So whatever we do to one side when solving equations, we always need to make sure we do it to the other. So what's 7 times 2? 14. So we have 14 ice creams, which we all figured out. So that might not have been what you were thinking in your head, like, oh, I'm just going to set this up as an algebraic equation. That makes so much sense. But that's what's happening. Even though it might not be your thought process entirely, this is what you're doing in your head, and this is how you're solving. So this was just a very simple way of introducing or solving equations, a very simple practice. Most of the ones you won't have to do won't have a word problem. You have to make up something. It'll be given an equation, but we want to be able to reintroduce those steps. So we do have like 4 or 5 steps for solving equations that you can cycle through every time. So every time you run into an equation that you need to solve, you can cycle through these steps, and they, as long as you do them correctly, it should always give you your answer. So step number 1, and sometimes you don't need all these steps. Sometimes you do, sometimes you don't. It really depends on what equation you have. But step number 1 that you'll run into, this is, let's see, we'll start with distribute. So distribute, that's a math word. What does the word distribute mean?
to hand out.
To hand out. So if we were English, if I were to distribute papers to you, I would hand out a paper to each person. So if we're doing math, what does distribute mean in math? Actually,
You distribute the
distribute the number. Okay, good. Wyatt. When do we need to distribute? What's a good sign?
the one where like they're on 2 sides equal in the middle.
Not quite. So when we're going to distribute something, we're always going to have parentheses. So anytime you see parentheses in an equation, you're going to instantly think, oh, I'm going to need to distribute. If you ever have a number on the outside, say 2, and you have something inside, let's say x minus 3, you're going to distribute hand out that 2 to each thing inside the parentheses, to each term inside. So distributing will always be multiplying. So we're going to multiply 2 times 3, or I'm sorry, 2 times x and 2 times 3. So what's 2 times x? How would I write that? Just 2x. It's going to be a coefficient. So coefficient is always that number in front of the x. What about 2 and negative 3? Negative 6. So remember that that value in front, that sign, will always stay with the number as well. If I had a negative in front, it would be a negative 2, that would be a multiplying as well. So that's step number 1. Always, if you ever have parentheses, you should always start with distributing. Sometimes you won't, sometimes you will. It might show up in the. So that's step number 1. Step number 2, after we distribute, we're going to simplify. Actually, I'm not going to simplify, that's a little generic. We're going to combine like terms. When I say the words combined like terms, what does that mean to you?
Two numbers that are the same or alike and combine them.
So what do you mean same or alike?
Like 2s and 2s go together to make them 4.
Can I do a 2 and a 7?
Yeah.
Why?
Because
So what makes something a non-alike term? Why don't we combine these? So one has a variable, one does not. So if it doesn't have a variable, the word we use for that is constant. This is a constant number. It's always negative 6. It's not changing. But this is a variable because it has an x in it. So any numbers that have the same variable can be combined. Any numbers that are constants that don't have any variables can be combined. So we're always going to combine like terms. So if we had, let's say, 5x plus 3x minus 6. What would I combine there? 5 and 3, they both have an x in them. It gives us 8x, and then minus 6, and we won't do anything with that. Okay with this?
Yes.
So once again, you might need to use this step. You might not. It might show up. It might not. So that will be your step number 2. So step number 1, distribute. Step number 2, combine like terms. Step 3. Step 3, we will inverse the coefficient. No, I'm sorry, not the coefficient, the constant. What is the constant again? Which of these numbers were the constant? The 6. What? So any number that didn't have that variable should be the constant. So that's 6 by itself. We would need to inverse that. Once again, inverse means do the opposite. So inverse will always do the opposite. So if I have, say, 8x minus 6 equals 4, in order to inverse that constant, I need to take that constant, I need to move it to the other side. So how would I do that? Right now I have a subtraction, so I'll add 6, and then we would get 8x equals 10. So always inverse that constant. But once again, if you do something to one side, you always have to do it to both sides. Make sure it's even. We want to keep that equality. One last step. We got rid of that constant. What do you think we need to get rid of next?
The 8.
The 8. What's a good word we can use to call that 8? We can call that number in front. Coefficient. Good. So that number in front of the variable, it's always going to be called the coefficient. So in this case, we have our 8. And this over here, we have the 2, we have the 5, the 8, the 3. So those are all the coefficients. Typically, in order to inverse the coefficient, the coefficient is being multiplied by. What would be the inverse of multiplication? Division. So we would divide this problem. We would divide by 8. And I didn't really work out this problem very well. But we're going to get an ugly number with that. But sometimes, like what we had ahead, that coefficient was being divided by. So there are situations where you will need to multiply to get inverse the coefficient. But 8 out of 10 times you're going to inverse by dividing. So yeah, 8x 4. And then you should, assuming you follow all those steps, the ones you need, you should end up to where you have your x by yourself. Is this jogging back a little bit of your memory, bringing a little bit back from 8th grade? Good. Good. All right, so let's practice some of these. Now that we have this list, we have these 4 steps that we're going to follow. Let's practice. So we'll do the first one together, and then I'll let you do the second one on your own. We'll do the first one together. So, all right. So step number 1. Step number 1, I need to distribute. Is there anything to distribute in this problem? No, we don't have any parentheses. The parentheses are always your telltale signs. Combine like terms. Can I combine any terms? No, once again, can't do that. What's step number 3? Inverse the constant. What's my constant on this problem? 11. So it's currently, I'm subtracting 11. It's a negative 11. So I will add 11 to both sides. So we get 3.5x equals 17 plus 11 is 28. Awesome. 28. One last step. Inverse my coefficient. So what should I do then? Divide by 3.5. I already forgot what the answer is. Should be. And that is our answer. Are we okay with this? How can we check this problem? Check this answer. I can take that 8. I can plug it back into my x. So I would have 3.5. I just substitute that x with my 8. And I want to see if this equals 17. So 3.5 times 8 should be 28 minus 11. This equals, sorry, if I can write, 17. So this checks out. So it's correct. All right, take a moment. See if you can do this second one on your own. If you have a question, let me know, and I will do my best to answer. So what did we end up doing for this problem? What was your first step? Go and walk me through. So we need to get rid of that 11, that constant. So we would subtract 11 to cancel those out. So what is negative 13 minus negative 11? Positive 24? Negative 24. And once again, that negative, that's minus 4x is making that a negative 4. So we want to make sure to keep that sign with the 4. What would you do next?
Negative 4.
Divide. What am I dividing by? Negative 4. What's a positive divided by, or what's a negative divided by a negative? Positive. So I will get a positive 6. Awesome. And then you can go back if you want, check your answer, plug 6 back into your equation, and it should check out. Are we okay with this? Questions, concerns?
Yes. Why did my 10%?
You did it.
Good to know. All right. What do you notice about this problem? This next one. So we have 2 x's. So what do we need to do those x's?
Combine them.
Combine like terms. So 15x minus 8x. How can I combine that? So what would that become? 7x. So I have 7x plus 13, and that is still equal to my negative 8. So now I'm back to my 2-step equation.
Oh, you do minus 13.
I need to inverse my constant.
And then
So what's negative 8 minus 13?
One more negative 20.
Negative 21. Got a lot of negatives today. Inverse my coefficient, so I divide by 7. Good. So a negative divided by positive will give me still negative. So x equals negative 3. We okay with that still?
Yes.
All right. Take a moment. Try the second one. Okay, so what was different about this problem than the other ones? We have two variables on each side, or we have a variable on each side. So in order to solve this, we need to make sure all those variables are on one side of the problem. We need to get all over to one side. So how should I do this? What should I do? Which one should I move?
You do 2x minus 3x, right?
So you're going to subtract the 2x? This might be different from what you did. You might have subtracted the 3x, and that's okay. You'll still end up with the same problem. Typically, people like to subtract the smaller one. So the 2x is a smaller coefficient, so you subtract that. That's okay. It doesn't really matter which one. I could have subtracted 3x. I would have still gotten the same answer. So that might be different from what you did, but that's okay. So what's 3x minus 2x? Just a single x. And then I still have that 7.5. Is this 5 now? What is it? Negative 5. That minus sign is still going to stick with him. Last step. Minus 7.5. What's 5? Negative 5 minus 7.5?
12.5.
Positive?
Negative.
Negative. Good. Always watch those signs. Do I need you to divide by 1?
Yes.
If I were to divide by 1, cancel that out. What's going to happen over on this side? It's going to be the same. So if you ever have 1x, you can just leave it as x. You don't have to solve it past that. But if you really feel like you need to divide by 1, go for it. But it won't change your problem. So negative 12.5. So even though there might be the two variables might be intimidating, just remember, get them all to one side, and you'll be okay. What do you notice that's different about this one?
W. They are separated.
So we have a different variable. Okay, yeah, I have a W on this one. What else is in there? What are those one things called? Parentheses. How do we get rid of parentheses? What do we need to do? We need to distribute. So everything is going to get that number on the outside. So I'm going to multiply 3 by everything inside the parentheses. So the 2 will be multiplied by 3, which will give me 6. And the negative W will be multiplied by 3 as well, which will give me a negative 3W. Then I still have my plus 4 on the outside. And this equals negative 8. What should I do now? What like terms do I have? 6 and 4. What would that combine to?
10.
10. So 6 plus 4 gives me 10 minus 3W equals negative 8.
And then you do minus 10 to both sides.
I need to get rid of that constant, so I'm going to minus my 10 to both sides. That cancels out. So what do I still have left on my left side? Negative 3W. And what gives me on my right side? Negative 18. And to solve? Divide by negative 3 to both sides. So negative 18 divided by negative 3, what would that give me? 6. So W equals 6. Awesome. Think you can do the last one on your own? Okay, really quick, walk me through this last problem. What should I do first? Distribute. What would that give me?
Negative 6.
So negative 6 minus 2. So that negative 2 times negative 1 will give me still a negative 2. Negative times a positive is a negative. Okay, what should I do next? Add 2, so I need to get rid of that constant, so I'm going to add 2. Negative 17 plus 2 gives me negative 15. Last step.
Divide 6.
Divided by negative 6. And what is that? 2.5. Awesome. So I handed out some work to you. This is not homework.
Process